There we go. Okay, so we've broken down this OSC tutorial into 3 parts. So should be the third and last part. And we're going to talk about running jobs on the cluster. So I said at the end of the last lecture that when you log on to OSC, when you're working in the command line, you shouldn't be running any kind of scripts there. The login nodes are only for light computation. You're checking some really quick and easy things. This text says, think about when you're running something on your computer. Maybe you're running some R script that takes a lot of computational power from your computer, and it makes browsing the internet and checking your email a lot slower. So when you do not run heavy things on the login nodes. The way to do this is to set up scripts and submit the scripts as a job. When you set up your script, you're going to ask for some resources, some amount of memory. You're going to tell it how much time you think it should take to run this job. You're going to ask for resources. You're going to tell it what project you're charging back to, because every time you run any kind of script on OSC, it gets charged back to your project. Now, right now in this class, you're using the class project. So that's all taken care of right now. After you're done with this class, I will kick you out of the project. And if you want to continue using OSC, have your PI set up a project. Now, I told you that everything you run is associated with a cost, but PIs who work in the state of Ohio and who have OSC projects, they get $1,000 every year as a stipend to spend on OSC resources. So it's basically free because OSC gives you money to use as long as you're working at an Ohio university. So talk to your PI if you want to keep using supercomputer in the future. It's a valuable resource. So how are we going to prepare these scripts? Instead of typing commands on the command line or making a script that we run from the command line, we need to make a file that we set up. It gets set up with a header that defines the resources that we need to use to run this job. It changes the directory into where we're working, and then it has the script that we're going to use. I'm going to copy and paste because I trust my copy and paste, but I encourage you to not copy and paste. I say it over and over again. Don't copy and paste. Okay, I just opened up my putty. We're going to change into our project space 1669, and I'm working in OSU 0972. Okay, CLI. Don't know if we're supposed to be in CLI or not. I'm just going to be here in my folder in the project space. If you're starting from the last lecture and you're in CLI, that's fine. Okay, we're going to start out. We're going to open up VI GC content. I think .sh, no, .srun. .srun. Okay, we're opening up a file. You are going to type all of this information into your file. We hit I for insert. You can't type anything into your file until you hit I. Make sure that this says insert down there, and then you're going to type all of your information. I can type it very fast. Don't be like me. Okay. So we start out with a header. Every single header has to start out with #, exclamation point, /bin/bash. And then we have our sbatch header lines asking for resources. We ask it for however many nodes, however many threads we want. We say we want this much memory this script is not going to need all of these resources, but this is what we're asking for. We ask for 5 minutes of time. We give it a job name, and we say this is the account that we want to charge back to. So the amount of resources that you want to request in your header need to be slightly more than what you need. Like, if you know that your job is going to take 5 hours to run, I would ask for 10 hours. So something very slightly more than what you need, because when this time is over in your script, the script's going to be finished, regardless of whether what you're running is finished or not. But the drawback is when you ask for more time, when you ask for more memory or more nodes, it's going to take that much longer to actually get down to where it's your turn in the queue of jobs to run. So there's a trade-off. You want to ask for as much as you need, but not so much that you never get your turn to have your jobs run, because there is a queue and lots of people are running things on the supercomputer. So things get lined up and you'll get your turn based on some sort of priority. So be aware of that. Okay, then we've changed into this Slurm submit directory. And when we use this interface of Slurm submission, this is a variable that means the directory where I submitted my job from. And that's all that it's doing, is changing in to where your script was submitted from. And then it's going to run this script. And you'll see it has a variable for input and a variable for output. And we're going to define those variables while we're submitting jobs for the script. Okay. When I hit escape, it makes this floating panel pop back up again, which is a little annoying. Okay. I didn't even talk about. Okay, so we were in insert mode. I hit escape to get out of insert mode. Then I did :WQ to save the file and quit. Now we're back to our command line. We're going to go back. We're going to submit the job by using this line that we're going to type out in the command line. It's going to submit the job from the command line. My mouse pad is buckling, and so it's hard to highlight things. But what it's doing is this S batch means submit this job. And then we're telling it that we're going to give these variables to our job through this export option. We tell it the input variable needs to be chromosome22.fa, and the output variable needs to be chromosome22.fa.newOut. And this is our script that we're running. So it's going to submit a job of the script with these variable inputs. Okay, so go away, floating meeting controls. Okay, on the command line, you're going to type this command. I'm going to paste it. Okay, and you can see when we hit enter, it says submitted batch job, and it gives it a batch ID. If we do squ.u and your username, so sq-u and your username, we're going to see our job. And so it has our job ID, it has our job name, it has my ID username. It tells us that it's running. So that R means running. If it's a Q, it means it's queued. If it's a C, it means it's completed. It tells us the amount of time that it's taking, the number of nodes, and what node it was assigned to. So think about OSC as a lot of different nodes. And so when you submit a job, that job and all of its inputs is going to go to one of the nodes, which is like a little tiny computer. It's going to run on that node, and then all of the information is going to come back to you. If you need a lot more computing power, you might use a couple of nodes, and then it all runs and it all comes back to you. I try SQ-U, my name again, and the job's not even there because it finished. What am I supposed to be talking about? Okay, let's just look at the what got created. So here is our script. It's an srun file. Here is our slurm output file. What happens if we cat that? Oh, so my slurm output file says there is no chromosome 22 FASTA file here in this folder. So this is telling me I need to make sure chromosome 22.fa is here where I'm working. Now, I know that it is in this CLI folder, but the supercomputer does not know, because computers only know what we tell them. And I've made a mistake and I've run the script without my input file. I wasn't planning this, but this is good. Okay, chromosome 22.fa.new out. This is the output file that got made when my job ran and it failed. And it's blank because the input file is not there. It still made the output file. There was no output to print to it. So what do we need to do? There's some options. So we could go into CLI, we could remake all the scripts, and then we could run them again. We could move our script into the CLI folder, or we can move our FASTA file out of the CLI folder. So I'm going to do MV GC content. This MV command means move, and I'm saying move GC content.srun, and I'm saying put it in CLI. So I type my folder name and a slash, and that's going to move my script. It's not here anymore. It's been moved into CLI. So now my script and my input file are in the right place. We're going to go up, 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 up. Okay, so this is that line of code of the command that I used to run my script the last time. I'm going to run it again because I ran it badly before. So now we have a new batch job. We do SQ, no, SQ.U, OSU 0972. And now it's running again. What kind of files are here? We have our slurm output file that just got made. As this job runs, it's going to print to that output file. Let's check to see if my job's done. Job's still running. Let's cat our output file. There's nothing there yet. I don't know if anything will get printed out, but it's running this job. It's taking our chromosome 22.fa. It's doing the command, and then it's exporting chromosome 22.fa.new out. How's this doing? Still running. Okay, let's see. It's taking a minute. Okay, let's go see while that runs. Make sure I went over everything. Okay, remember when you VI a file, you need to hit I to turn it into insert mode. When you're done typing, hit escape :WQ to close that file. Okay, so once that runs, we're going to learn how to do automation with our job submission by using a loop. Let's go check. I'd like to talk about this first. Yeah. Okay, so our job ran. Let's see. We have our slurm output file. We'll cat that. There's nothing there. Nothing was printed to the screen when we ran our script, and there were no errors. So nothing is in our output file, which is usually a good sign. Let's look at the file sizes. we look at the file sizes, we see our chromosome 22.fa.new out. There's something in it. Where before, this was the one in the outside of this folder, it was 0. So the one we made before, when the script failed, the file size is 0. But when we look at the file size of this one right here, it's more than 0. So that means there's something in this file. So let's cat chromosome 22, I'm gonna tab. There is a chromosome 22.fa. So when I tab, it stops here. But I know I want to do dot, and I'll tab again, fills in the rest of the word. Let's cat that. And this is an accounting of every single character in our chromosome 22 FASTA and how many times we saw that character. If you think back to our last lecture, when we ran this same command with our test.sh script, we ran that and it printed to the screen. This way, when we have, let's see, this time we have our input variable and we have our output variable. And we defined our output variable in that sbatch command script right here. We defined our input and our output. And when the script ran and got put together, it plugged these values in at runtime and made everything work. You'll notice in the sbatch command, we do not have the $signs. But when we're referring to that variable in the script, we have $signs. Remember that. Okay, I'm not going to run this again because we've done this 2 different ways now. Now we're going to do it the third and final way. Job submission with a loop. First, starting out, we are going to highlight this, copy it, open. This is our submit srun shell script. It's a new file. We hit I. Now it's ready to type. I'm going to show you why we shouldn't copy and paste. I'm going to copy this and I'm going to paste it. Oh, it worked. It worked this time. So if you'll see these lines in this shell script, they have pound signs. And much like our coding, when we want to comment something out, we start the line with a pound sign. But if you'll notice, these lines, they're too long to fit in this little HTML tutorial, so they split over to the next line. I have seen students, when they type this in their script, this job scripts line will be on its own line and it doesn't have the command symbol in front of it. So R thinks this is something so the Linux command thinks this is something I need to run, and then it has an error. So just make sure all of this commented area, you don't really need it, but it's for your information to understand how is this job working. It's information. And it's all commented up here in blue because it has pound signs or hashtags, whatever you want to call it. Has information about using this script. And if one of these happened to be like that, then that would throw an error because this needs to be behind a pound sign. Okay. So what is the script going to do? Is there information? Okay, I will talk about it. We have our information for the user. So this is a loop. So while there is inputs and outputs to read in, it's going to do this. It's going to print out the in variable, and it's going to submit this job. So it's going to use sbatch to submit a job. It's going to tell us export these variables. Our input is equal to n, and our output is equal to out. And the script we need to run is gccontent.srun. Tell it to take a little break, go to sleep for 5 seconds, and then you're done. As long as there is input that it's reading in right here, is going to keep running. Where is it going to get this input? It's going to get it from whatever value we provide to run the script with. It's going to be read in right here with this $1, which means the very first argument as we run the script. So make sure your script looks like this, with all of the comments commented out, with line breaks like this. We don't want any extra stuff anywhere. So type, don't paste. Hit escape, hit colon, WQ. Make sure the W and Q are lowercase. Sometimes I type it too quickly. They end up uppercase, and VI complains. Okay. So we've saved it. And we now have a submit script. Away. Loading meeting controls. Okay. We have our submit srun shell script. Now we need to change the permissions to this shell script. There's 2 different ways to do it. If you remember, we did the UG for yourself and your group plus X for executable. There's also a code that means the same thing. And if you just look up the code, you'll know which number to use. But you do one of these things to change the mode of our submitter script. Change mode, UG plus X, submit. Yeah, now enter. Let's look at it because it's going to be a different color. Anytime you turn a file into an executable, it's going to be a different color. And here it's green. We can look at the permissions, and now it has these X's. Green files have X's for executable. Now we're going to prepare a file of variables. Sometimes I call this a manifest file. It's going to be, every line is going to be one job, and you're going to fill in this text file with several different jobs. I'm going to copy and paste, but I don't want you to. I have a hard enough time copying and pasting. There we go. Don't be like me. Okay. So what are we doing? We are echoing this value into A. We are echoing another value, concatenating it onto A. And then the same thing with B. We're going to print out test.out into B, and then chromosome 22.out into B. So what does A look like? And what does B look like? This doesn't make much sense as we're doing it right now, but then we paste A and B. And pasting, cat concatenates. We're pasting, it's going to combine it by the columns. So when we paste A and B into info, we cat info, it's going to be A is right here and B is right here. So this is our input file for our submit srun shell script. At this. So we're going to run our shell script, and the input is going to be this info file. And what is that going to do? It's saying, while we read the info file, the first column is our in variable. The second column is our out variable. And it's going to run a job for every line of our info file. So let's see. Okay, so to run our script, we do this. We do /submit srun.sh, and we tell it info. That is our one variable. And what is it doing? It's submitting two different jobs. Okay, so it submitted a job for the test line, and it submitted a job for the chromosome 22.fa line. Do we have a test.txt? We do. Okay. I was thinking that the first job wouldn't do anything, but we have two jobs going. First has this job ID, ends in 44. The second have this job ID, ends in 53. So let's see what that's doing. 72. One of them is finished. It was fast. What's going on? Okay, so we'll wait a little bit for the second one to finish, but the first one really did. So I've already done this SQ-U username if you want to see how your jobs are running. If you have submitted some jobs and maybe you realize you need to change something, then you can run this command scancel and tell it your job ID, and it's going to cancel that job. That way going to. Okay. So think about that. If maybe you've submitted some jobs and you realize that you haven't set the right heading parameters, or it's going to take too long to wait through the queue, maybe you need to cancel your job and change something about it and then resubmit it. Okay, all of my jobs are done. Let's cat our info so we know what to look at. Okay, so the first time it ran, its input was test.txt, which is this, and its output was test.out. What does that look like? It's this. It took every character out of that test file and told us how many times does this character happen in the file. And then the second job that we ran on the second line of info. The input was chromosome 22.fa. The output was chromosome 22.out. So what does that look like? .out. It tells us from all of the characters in chromosome 22.fa, how many times does each one of those characters happen? And if we cat chromosome 22.out and chromosome 22.fa.newOut, it's going to be the same thing. That's the main thing I'm going to be looking for in your homework. You're going to tell me your working directory, and I'm going to go there, and I'm going to cat your chromosome 22.out and your chromosome 22.fa.newOut. So make sure those two files are there. That's what I'm going to look for. Now, everything that I've showed you so far has been job submission from the Slurm job scheduler. There is a different version of a job scheduler called a PBS scheduler. And that's what we used to have on OSC. And in the last couple of years, we switched to Slurm, but you could really use either one. PBS still works. I use PBS because that's what we were using for the past 15 years. So that's what I like most. I'm going to sneeze. It's going to have a slightly different format. So instead of SBatch for requesting resources, it's going to be PBS for requesting resources. And there's certain ways of indicating your wall time, your memory, your project that's very slightly different than what we did up here. So use whatever you want. Doesn't matter to the job scheduler. It doesn't matter to me. You can try out these PBS scripts if you want, but it should make the same thing. It also works with the loops. It's just slightly different commands. So instead of using SQUU to check out what jobs are running, you use QStat. Instead of using scancel to stop a job, you use qdel to stop a job. So I will use these commands because that's what I think of first, because that's what I've been using for so long. It's like a different language. If you're used to speaking one language, translating from that language to another language regularly is kind of hard. So I speak PBS and I have no reason to translate back out to Slurm. But since most of you are learning this brand new, that's what OSC uses, so I suggest learning Slurm. Okay. Now, I told you you should never run computationally heavy jobs from the command line, but it is possible to have an interactive job, and these are the commands that you could set up to run an interactive job. You need to specify your project, your amount of time that you want to use, and then it will pop up an interactive command line just like this, but instead of being on the login node, you'll be on one of those job submission nodes. It's useful if you want to debug something and get an immediate answer. What is this going to do? Is this line of code going to run, or is it going to give me an error? So we've learned how to submit jobs to the supercomputer, which is how we should all be running our commands. But part of running these jobs, you'll be using programs that you might want to use to analyze your data. Like you have raw FASTQ files, you want to map them to a genome. Okay, so you could download those programs and install them in your own project space. I have a lot of them. So we usually keep them in our bin, which is where you keep programs you've installed. I've installed lots of programs just because I need them. Maybe I want updated versions. You have to keep updating them. But OSC is really nice because they have taken some of these programs that lots of people want to use and installed them for you on OSC. Let's see, OSC modules. There are lists. Oh. Computer. They have lists of what software is available on their webpage. Yeah. So maybe you wanted to map your reads to the genome. You would use HiSat2 because that's the latest and greatest. It tells you what version is installed on Owens and what is on Pitzer. And it tells you a little bit on how to use this program. There are some programs, like let's find SamTools. SamTools right here. SamTools has a lot of versions installed. And some of those versions are available on Owens. Some different versions might be available on Pitzer. I think Cardinal is the brand new processor. I've never even used it. Brand new cluster. It has an even more different version. So if you were to ask for SamTools version 1.3.1, but you were logged into Pitzer, you would get an error because that module version is not available on Pitzer. So if you're building your own scripts and you want to get an idea, what version should I use? Check out these websites. I would use the latest version that you can, but just know that some versions are on one cluster and not on the other. Now it is possible. So we load a module by module. Let me clear out all of this. It's module load SamTools. You could just load this and it would load the default version. I think there's a star. It's going to be 1.10 regardless of which cluster you're on. But if you wanted to load a certain version, I'm gonna have a slash, and I'm gonna tab and ask what versions do I have available. I'm gonna get 8. So it says it's replaced 1.10 with 1.8. If you want to know what modules might be available, module keyword SAM. So it's going to pull out any module that has SAM as part of its name. And we can see there's 1.8, 1.10, and 1.16.1. When I set up scripts, I like to be clear with the version that I'm using, because if I just say module load SAM tools in a script, and then 10 years from now, I'm going back to that script to see what programs I was running, I'm not going to know what version of SAM tools was available 10 years ago, unless I explicitly stated load this version. So that is my warning. What are we on? Yeah. So once you load that module, we've loaded SAM tools. We can type SAM tools, enter. And since we got the user guide for SAM tools, we know it's in our environment. We can use it. This is a lot like when we ran R and we loaded packages. Loading a module is like loading a package into your environment. Let's see. I've never done this. You can do which SAM tools. I don't know. Okay, so it tells us which SAM tools is loaded into our environment. You can do module purge to unload your modules, and it will take those directories out of your path. Your path is where you have programs that can be run. You can also remove modules by name. You can list what modules you have. Sometimes if you load a module like R, load R, what modules we have. None of them are like that. But in the past, some of these R modules, they needed other things. Let me load this. So this particular R module needs MK1 and GNU of particular versions. So it did it automatically. But if you want to know what other modules does my module need to work, you can do module spider and R.4.0.2. Okay, yeah, so here's the one without the special GNU. And it tells me to load this R version, I need to load this version of new. Or I could just do the one that has that version already packaged with it. So if you're having trouble loading some package because it says you don't have the other modules that are needed to run this module, try Spider. It will tell you what else you have to load. Okay, so that's all I have to talk about today about OSC. So try all of these things out in the tutorial with special care for running these GC content scripts. Let me know your path from where you're working, and I'm going to check for those 2 output files. Okay, thank you.